starting section 5.3. Okay. We did 5.1 translations, 5.2 reflections, and now we're going to do 5.3 rotations. So a translation was just moving something. You just moved it. A reflection, you need those. Yeah, I think you and Colton both need them. A reflection is turning it. A reflection is flipping it, like where you flip it over. And a rotation is where you turn something. Okay. So whenever if you have the knobs on your bathroom faucet, well, pretty much any of them, really, even the levers, all of those are rotations. So if you take a bath every day or a shower every day, you're using geometry. You're doing rotation. One thing I can think of is flag twirlers, in band, and baton twirlers. They are doing rotations every day. So some of your vocab terms I have on here, but I'm not going to read out like the vocab on there. What I'm going to do is label it and show you where it's at on the picture. So that's what I need you to do. All right, so for a rotation, you have something that's turning, and then you're going to have a center of rotation. Depending on where that center of rotation is, depends on how that item turns. So what I need you to do is on your paper over there on student notes, you see this point P here? I need you to label that center of rotation. So label point P, center of rotation. And you see where it's pointing to that 40 degrees? That 40 degrees is your angle of rotation. Okay. So what the center of rotation does, it tells us where does it stay the same? How is it turned? Like where is it turned from? And the angle of rotation tells us how much to turn it. Okay, so let's say I have this ruler. Let me show you the difference in center of rotations. Okay, I'm going to put it on the board. Let's say that this right here is my center of rotation, right here where my finger's at. Then that point is going to stay there, and this ruler is going to turn in the same location, just like this. Okay? That's at the center, is the center of rotation. Now, watch the difference if I were to change my center of rotation. Now, instead of it being in the center, now I'm going to make my center of rotation over here. Notice the difference. See how much of a bigger circle it's making? Because I changed my center of rotation. So it goes from that, at that end of it's the center of rotation, to this right here. Okay, it's my center of rotation. So notice how differently it turns. The angle of rotation is how much you turn it. Okay, so let's say it starts here, and I want to turn this 90 degrees counterclockwise. So here's 0. 90 degrees would be it would make a 90 degree angle from where it originally started. So this would be 90. 180 would be all the way over here where it makes a straight line. 270 would be straight down, and 360 would be right back in its original spot. Those are the only ones we're going to do. We're not going to do 360. We're just going to do 90, 180, and 270. So we're just going to do 90 degree rotation, 180, and 270. Okay? And the reason we're going to do those, and the reason we're always going to do it counterclockwise is because there are rules you can follow. All right, coordinate rules for rotations about the origin. The first rule says, when a point AB is rotated counterclockwise means backwards up from a clock, about the origin, the following are true. Our center of rotation is going to always be the origin. I'm not going to change it up on you and tell you the center of rotation is going to be 0.11 or 0.1 negative 1. Our center of rotation is always going to be the origin, just to make it easier on us, because we already have a lot of rules to remember anyway. All right, so for a 90 degree rotation, AB becomes opposite of B, comma A. So notice you need to fill that in over there on student note, on teacher notes. where it gives the rules. So for a 90-degree rotation, it becomes opposite of B, comma, A. So that's what needs to go on that line. Okay, now, on student notes, you need to put what that means in your own words. You know how we did those? Like y equals x, b comma a means to flip x and y. What does this mean to do?
Flip x and y, change the y.
Yeah, but it's now the new x. Okay, so yeah, so let's say flip your x and y and then change the sign of y. Flip your x and y and change the sign of y. Now it's the original y, not the new y, because once you click on y is now x. And what I do is I change my signs first, then I flip it. That's what I do, that way I don't get confused. Okay, so flip your x and y and change the sign of y. Or if you wanted to say change the sign of y, then flip x and y, that's also okay. All right, for your next one. For a rotation of 180 degrees, AB becomes opposite of A, opposite of B. Opposite of A, opposite of B. So negative A, negative B. What does that mean to do in our own words? Yeah, just change both signs. You don't have to flip anything. All you got to do is change the signs of both X and Y. And someone made had a good question first hour was, why did they use A and B and not X and Y? It's a really good question. I have no idea why the book uses A and B and not X and Y. I guess because it just represents numbers. Do what?
Things like less confusing than I don't know.
You think so?
Yeah.
So I thought about changing it next year to X and Y, but you think that would make it more confusing?
For other people, but
Okay. I just go along with what the book does. All right, and the last rule, for a rotation of 270 degrees, AB becomes B, comma, opposite of A. B, comma, opposite of A. What does that mean to do?
change x and flip them.
Change your X sign and then flip them. Change your X sign and then flip X and Y. Change X and then flip X and Y. All right, what questions do you have for me before we actually get started on some actual problems? Okay. All right, so the first one's a teacher model. Remember, with teacher models, I do this one completely on my own. You just need to pay attention and copy down what I write down and put any side notes down that you have, anything like that. All right, it says, graph quadrilateral RSTU with vertices R31, S51, T5, -3, and U2, -1. Then rotate the quadrilateral 270 degrees about the origin. So what I'm going to do first is graph my original quadrilateral. So let's graph RSTU. Now, what I do, now that you know about vectors, I treat my ordered pairs like they're vectors. You just always have to start at the origin. So +3, +1 would mean go right 3 and up 1. So you start at the origin and go right 3 and up 1. So that would be R. S is to the right 5 and up 1 from the origin. T is to the right 5 and down 3 from the origin. And U is to the right 2 and down 1 from the origin.
Is that F, right?
R, S, T, and U.
Okay.
Sorry, I talk kind of weird.
No, it looks like it. Yeah, we just signed those letters. We just signed it. Okay, we'll do them. Still better.
There. Let me fix this line and don't look too pretty.
Is it hard to draw with that board thing?
Yes.
Do you just have to guess where you're at?
No, you can see the pin.
Oh.
All right, so now I need to go back and remember what that rule is since we have so many. For 270, it's B, comma, opposite of A. Alright, so I'm gonna write that down, b comma opposite of a. And what that means is you change the sign of x and you flip them. So I go through before I even flip them and I change every single sign of it, every single x value. So 3 becomes a negative 3, s becomes a negative, or 5 becomes a negative 5, this 5 becomes a negative 5, and this 2 becomes a negative 2. Now I go through and flip all of them. So r prime would be 1 negative 3. S prime would be 1 negative 5. T prime would be negative 3 negative 5. And U prime would be negative 1 negative 2. Okay? And make sure you're checking my math. Like if you see me that I forgot to skip something or left off a sign, let me know. Okay? Alright, now that I have all my new coordinates, now I can just graph my new quadrilateral. R prime is 1 negative 3, so that means start at the origin and go right 1 down 3. So right there is R prime. S prime is 1 negative 5, so go to the right 1 and down 5. T prime is negative 3 negative 5, so that means start at the origin and go to the left 3 and down 5.
You think you get a smart board?
Yes. And U prime is to the left 1 and down 2. A smart board would be really good.
It's probably got one. She does? She got a minimum one here. It's really small though, like it's not nowhere near the size of that. So
Okay.
it's up to-
Alright, so there's my new figure. Now, your figure, the size and shape should not have changed. Mine might look like it did, but that's just because I can't draw a straight line with that thing. So what happened was, it's like you pretty much took this whole graph and you took this axis in this picture. If I were to rotate it 90 degrees, it would be located here. And then 180 would be here, and then 270 would be here. So notice like what was, like RS was on top. Well, when you rotate it 90, it comes to the side. 180 RS would be at the bottom, and then 270 RS is over here at the side. Okay, so it's like as it goes, it turns. So like my hand was facing this way. Oh, sorry. When I turn it, it's facing up, left, down. Okay, and then when I go back to 360, it's back to where it was. All right. What questions do you have for me? All right, let's try one together. Hopefully there's a triangle that it's easier to see, or a more normal shaped quadrilateral. All right, it says graph triangle JKL with vertices J30, K43, and L60. Rotate the triangle 90 degrees about the origin. So first thing you're going to want to do is graph J30. Now my question, do I do right 3 or do I go up 3? Hayden, what would you say?
Over 3.
Over 3. So that would be right there. So that's J. K is 4, 3. So that's to the right 4 and up 3. And L is 6, 0. Okay, that's kind of like the 3, 0. So I would probably go to the right 6. Okay, so there's JKL. All right, now it says to rotate it 90 degrees about the origin, but I can't remember what the rule is for 90 degrees. Ben, will you look back at 90 degrees and tell me what the rule for that is?
Flip them and then change B.
Flip them and change B, so it's like opposite of B, comma A is the other side. Okay, so we flip them and change the sign of the Y value. Okay, so versus change the sign of all the y values. If I do,
I need a negative 0. There's nothing to do with that.
it would not be a negative 0, it would just be 0. All right, so 0 is neutral, so it's neither positive nor negative, so we just leave it at 0. This 3 becomes a negative 3, and this 0 stays 0. Okay? Now I go through and I flip them. So my J prime, what would be the ordered pair for J prime, Kyle?
0, 3.
Do y'all agree with that?
Or negative 3.
Ooh, which one is it? 0, 3 or 0, negative 3?
0, negative 3. No, negative. Yeah, negative 3. No. No, 0, 3 is a negative 3 is 0.
Yeah, the 0 is the one you would change the sign, but it's neither positive or negative. If you wanted to put negative 0, go right ahead, but you don't have to. So you were right the first time. All right, so now for K prime. Gabby, what would you say K prime would be?
Negative 3, 4.
Negative 3, 4, perfect. And L prime. Colton, what would you say L prime would be?
0 and 6.
Awesome. All right, so this is why I changed my sign at the beginning, okay? Because if you notice, it gets really confusing knowing which one to change because it says change B, but now B's in the front, so you're like, okay, do I change in the front number or do I change the actual Y now? So that's why I always go through, and if it says negative B, I go ahead and go through and change all my Y's, and that way when I get down here, all I have to do is flip them, okay? All right, so now let's graph these ordered pairs. J prime is 0, 3. All right, Aiden, where would that ordered pair be at? Would I go over 3 or up 3?
Up 3.
Yeah, you go up 3 because it's the Y value. So there's J prime. K prime, negative 3, 4. Ellie, how would I graph that point? What would I do? Left 3 and up 4. Good job. And then L prime is 0, 6. Andrew, where would that be?
0, 6.
0, 6, yeah.
3 up from J.
Perfect. So right there. Kind of right there. It's not really on the point, but we'll pretend like it is. 1, 2, 3. Hopefully I did that correctly. Now, your triangle should look exactly the same. It's just on the 90-degree axis rather than the 0-degree. So this is your 0-degree axis, 90-degree, then this would be 180 and 270. All right. Now that we've done 2, what questions do you have for me? Okay. All right, so we're going to stop right there. Put your notes in the front pocket of your binder. We're going to finish your notes tomorrow. Angie will be working in your student journal. So make sure you bring your student journal with you to class tomorrow. And you still got like 3 minutes now, but you can go ahead and put up your calculators and get your phones. Just make sure you have a seat while we're waiting on the bell.
Oh, yeah, that's so cool. All I need to do is